equations in two variables. A linear equation in two variables unknowns, say x and y, is usually represented in the following form: ax plus by plus c is equal to 0, where a is not equal to 0, comma b is not equal to 0, a comma b and c are real constants. Examples: 3x minus y plus 7 is equal to 0 and 7x plus y is equal to 3 are linear equations in two variables x and y. Pair of linear equations in two variables. Two linear equations in the same two variables, say x and y, are called pair of linear equations in two variables. The general form of pair of linear equations in two variables x and y is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0, where a1 comma b1 comma c1 comma a2 comma b2 comma c2 are all real numbers such that a1 comma b1 not equal to 0 and a2 comma b2 not equal to 0. Sometimes we call a pair of linear equations in two variables as system of linear equations in two variables. Solution of a pair of linear equations in two variables. Any pair of values of x and y which satisfies both the equations a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 is called a solution of a given pair of linear equations. Here we have two methods of solving simultaneous linear equations in two variables. One is graphical method and second one is algebraic method. Algebraic method further divided into substitution method and elimination method. First method, graphical method. Here express one variable, say y, in terms of the other variable x. Y is equal to ax plus b for the given equation. Take at least two values of independent variable x and find the corresponding values of dependent variable y. Take integral values only. Plot these values on the graph paper in order to represent these equations. If the lines intersect at a distinct point, then point of intersection will be the unique solution for given equations. In this case, the pair of linear equations is consistent. If a1 by a2 is not equal to b1 by b2, then the pair of linear equations is consistent with a unique solution. Here two different lines intersecting at one point. If the lines representing the linear equations coincides, then system of equations has infinitely many solutions. In this case, the pair of linear equations is consistent and dependent. If a1 by a2 is equal to b1 by b2 is equal to c1 by c2, then the pair of linear equations is consistent with infinitely many solutions. Here two lines coincides with each other. If the lines representing the pair of linear equations are parallel, then the system of equations has no solution and is called inconsistent. If a1 by a2 is equal to b1 by b2 not equal to c1 by c2, then the pair of linear equations is inconsistent with no solution. Here two lines parallel to each other. Solve graphically system of linear equations. X plus 2y minus 7 is equal to 0. 2x minus y minus 4 is equal to 0. Given equations x plus 2y minus 7 is equal to 0. Equation 1. 2x minus y minus 4 is equal to 0. Equation 2. Consider equation 1. X plus 2y minus 7 is equal to 0. Rearranging the terms, that is x is equal to 7 minus 2y. When y is equal to 1, we have x is equal to 7 minus 2 into 1. 7 minus 2, 5. Similarly, when y is equal to 2, x is equal to 7 minus 2 into 2. 7 minus 4, that is 3. Now draw table x, y. X is equal to 5, y is equal to 1, x is equal to 3, y is equal to 2. Consider equation 2. 2x minus y minus 4 is equal to 0. Rearranging the terms, y is equal to 2x minus 4. When x is equal to 2, we have y is equal to 2 into 2 minus 4. 4 minus 4, 0. Similarly, when x is equal to 0, y is equal to 2 into 0 minus 4. 0 minus 4, minus 4. Now draw table. Represent xy values. Xy. X is equal to 2, y is equal to 0. X is equal to 0, y is equal to minus 4. Draw x-axis, y-axis, 1, 2, 3, 4, 5, 1, 2, 3, 4, minus 1, minus 2, minus 1, minus 2, minus 3, minus 4. Now draw line 1 on the graph sheet. Now draw line 1. Corresponding points are 5, 1, x5, y1. Second point, x3, y2, x3, y2. Now join these 2 points. X plus 2y minus 7 is equal to 0. Now consider line 2. Corresponding points are 2, 0, x value 2, y value 0, x value 0, y value minus 4. Now join these 2 points. 2x minus y minus 4 is equal to 0. These two lines intersecting at one point, that is x is equal to 3 and y is equal to 2. 3, 2 is the solution of the given system of linear equations. Substitution method. In this method, value of one variable can be found out in terms of other variable from one of the given equation, and this value is substituted in other equation, then we get an equation in one variable which can be solved easily. To understand the substitution method more clearly, let us consider two equations. 7x minus 15y is equal to 2. Equation 1. x plus 2y is equal to 3, equation 2. From equation 2, x is equal to 3 minus 2y. On substituting x is equal to 3 minus 2y in equation 1, we get 7 into x, that is 3 minus 2y minus 15y is equal to 2. 7 into 3, 21, minus 7 into 2y, 14y, minus 15y is equal to 2. Minus 14y minus 15y, that is minus 29y is equal to 2 minus 21. Minus 29y is equal to minus 19. Y is equal to 19 divided by 29. Now put y is equal to 19 by 29 in equation 3, that is x is equal to 3 minus 2y. 3 minus 2 into y, that is 19 by 29, is equal to 3 minus 2 into 19, 38 divided by 29. 3 into 29, 87, minus 38 divided by 29 is equal to 49 divided by 29. Therefore, required solution is x is equal to 49 by 29 and y is equal to 19 divided by 29. Elimination method. Step 1. Consider the equations a1x plus b1y plus c1 is equal to 0. Equation 1. a2x plus b2y plus c2 is equal to 0. Equation 2. Step 2. First, multiply both the equations by some suitable non-zero constant to make the coefficient of the variable to be numerically equal. Step 3. Add or subtract the one equation from the other so that one variable gets eliminated. Step 4. Solve the equations in one variable x or y so obtain to get its value. Step 5. Substitute this value x or y in either of the original equation to get the value of other variable. Let us consider two equations x plus 2y minus 5 is equal to 0. Equation 1. 2x minus 4y plus 6 is equal to 0. Equation 2. Now observe y coefficient is 2 in equation 1 and y coefficient is 4 in equation 2. So we have to multiply equation 1 by 2 and equation 2 by 1. Multiply multiply equation 1 by 2 and equation 2 by 1. That is 2 into x, 2x plus 2 into 2y, 4y minus 2 into 5, 10 is equal to 0. 1 into 2x, that is 2x, minus 1 into 4y, 4y plus 1 into 6, 6 is equal to 0. Here add equation 1 and 2, that is 2x plus 2x, 4x plus 4y minus 4y gets cancelled, minus 10 plus 6, that is minus 4, equal to 0. 4x is equal to 4, x is equal to 4 by 4 is equal to 1. Substitute x is equal to 1 in equation 1, that is x value 1, that is 1 plus 2y minus 5 is equal to 0. 2y is equal to 5 minus 1. 2y is equal to 5 minus 1, 4. Y is equal to 4 by 2, that is 2. Therefore, x is equal to 1, y is equal to 2 is the solution of given two simultaneous equations. Nature of lines and consistency. The nature of lines and consistency corresponding to linear equations a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0 is shown in the table below. Now consider two equations 3x minus 5y plus 8 is equal to 0, 7x plus 6y minus 9 is equal to 0. Here a1 by a2 is equal to 3 by 7. b1 by b2 is equal to minus 5 divided by 6. So a1 by a2 is not equal to b1 by b2. System is consistent with unique solution, that is exactly one solution. These two lines intersecting with each other. Now consider two equations. 3x minus 4y plus 5 is equal to 0. 6x minus 8y plus 10 is equal to 0. Here a1 by a2 is equal to 3 by 6 is equal to 1 by 2. b1 by b2 is equal to minus 4 by minus 8 is equal to 1 by 2. C1 by C2 is equal to 5 divided by 10 is equal to 1 by 2. A1 by A2 is equal to B1 by B2 is equal to C1 by C2. System is consistent, dependent and having infinitely many solutions. These two lines coincides with each other, that is coincident lines. Next, 2x plus 3y minus 8 is equal to 0. 4x plus 6y minus 7 is equal to 0. a1 by a2 is equal to 2 by 4 is equal to 1 by 2. b1 by b2 is equal to 3 by 6 is equal to 1 by 2. c1 by c2 is equal to minus 8 by minus 7. Here a1 by a2 is equal to b1 by b2 not equal to c1 by c2. System is inconsistent with no solution and these two lines are parallel to each other.